Okay, this is Algebraic Reasoning, Chapter 1.1. We're dealing with Sequence 1 right now. Alright, so we have a series of toothpicks. Alright, so this first one has 2, 3, 4 toothpicks. So I'm going to go ahead and fill out the chart. So the first term has 4 toothpicks. The second term has 1, 2, 3, 4, 5, 6, 7 toothpicks. The third one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 toothpicks. Okay. And so what pattern do you observe going on? And pause if you want to take a second to look at it. But basically what's going on is we are adding 3. 4, 5, 6, 7, 8, 9, 10. So each term adds 3 toothpicks. Okay. So from 3 to 4 we can say 10, so that'll be that'll be 11, 12, 13, 14, 15, 16, 17, 18, 19. Now you may be tempted to put 22 right here, but notice it goes from 6 to 10. So we need to go up 4 steps. So we really need to go up 9 to 11, 12, 13, 14, 15, all the way up to, I think, 32, if that's right. So that's up a step of 3, up a step of 3. That's 4 steps. 3 times 4 is 12, so we need to go up 12 units. So that would actually be a 31, not a 32. Okay? So question, is this arithmetic or geometric series? All right. Well, if we pause, remember, arithmetic is you're adding or subtracting the same thing. Geometric is multiplying or dividing. That's a common ratio. So remember, arithmetic is adding or subtracting. Geometric would be a common ratio. So in this case, it's arithmetic. And the y is, well, it's arithmetic because it has a common difference. Now, D-I-F-F-E-R-E-N-C-E. Now that may be a common difference is a normal, is a not a term we put up in the vocab, but we figured you could pick up on it pretty quick. Common difference. Well, something in common, and we have the same difference. A difference of 3, a difference of 3, a difference of 3. All of these over here are the same, so it has a common difference. All right. So it's arithmetic because it has a common difference. All right. Let's pause and go to the next page. All right. Letter C. How did you identify the 10th term in the sequence? Well, back to the last page. We identified the 10th term by saying, well, X went up 4 steps. So I went up 4 sets of 3, or 12 steps. Okay, so because the x wasn't consistent at that point, I had to make the y value match it. The x value went up 4 steps. Instead of just, it was going by 1, 1, 2, 3, 4, 5, 6. Then it jumped 4, so I had to make sure the y value jumped all 4 steps as well, and they were steps of 3. All right. Identify the first term in the sequence and write a recursive rule. Now, identifying the first term. Now, what we mean by the first term is this is where x equals 0. That's the starting point. Identify the first term. That is where x equals 0, or aka your starting point. So x at spot 0. Well, if we know x of 1, if we go back and look at the table, remember we had x, y, we had 1, 2, 3, and we had 4, 7, 9. Well, if we go, we're going up by 3. We just need to go down by 3 to get to 0. So 4 minus 3 is 1. So your starting point is 1. Here, let me be consistent with my colors. Okay? X of n, x of any number that I want, I will take the previous term, so x of n minus 1. And what did we do from one step to the other? What did we do from this step to this step? We added 3, right? Not that step. What did we do from, this step to this step, and then to the next step, and to the next step? We added 3. So we are going to add 3, and that's our recursive rule. All right? If this x of n, x minus n minus 1 is still throwing you for a loop, basically remember, these are not something we necessarily add or subtract. They are just identifiers. They tell us what x are we talking about. So in this case, let's say I want x of 6. All right, my n value is 6. I'm going to do x of, 6 minus 1 is 5. Okay? And I add 3. Which that was, 11, 14, 7, no, 11, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So x of 5 was 23? No, I'm at the wrong thing. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. X of 5 was 16. Alright, and when you add 3, becomes, we realize that step 6 is 19 units, just like the chart we saw earlier. Okay? So this would be your rule. Your recursive rule. Alright?